All right, guys, this is our review for our unit circle test. You've got a couple days. Actually, you'll have the weekend to get ready for it. We're just going to go get right into it. Number one, find the value of A. The dot represents the center of the circle. So you have your angle right here that's 55 degrees, and you're looking for A, which is this arc that goes from that line where it intersects the circle to this one. And if you remember, the angle, the inscribed angle here is half of what the arc's measurement is. So if this is 55, then A is 2 times 55, which is just 110 degrees. So the arc is twice as big as the angle, which I think is going to help us on number 2 as well. So we're looking for A, B, and C. So A is this angle right here that makes these, using these two lines that we'll pretend cross where they're supposed to. So I'm going from right here to right here, this arc. And that arc is 129 degrees. So the angle that makes that arc is half as big as the arc. In number 1, the arc is twice as big as the angle, which means that the angle is half the size of the arc. So if A is 129, if the arc for A is 129, then A is going to equal 129 divided by 2, which is going to be what, 64.5 degrees. So A is 64.5. Now it wants me to find B, which uses this line here and this line here. The nice thing about B is when you look at its arc, it goes halfway around the circle. So its arc is 180 degrees, which means that angle B is half of that, 180 divided by 2. So B is just 90 degrees, which leaves C. And there's a couple of different ways we can do C. I know that all the way around a circle equals 360 degrees. I have this part, which is 129. So if I subtract that, and if I subtract 180, I'm left over with angle C. I take the whole circle and I subtract the two parts that I know. And I end up with C is equal to what? 51 degrees. Because it wants the arc, not the angle. It wants this arc out here for C. So there's your answer, 64.5, 60, and 51 degrees. Okay, number 3. Again, we're using this idea that the arc is twice the size of the angle, and it wants us to find A, B, C, and D. Just because it wants us to find it in that order doesn't necessarily mean that's the easiest way. Remember that in a quadrilateral that's inscribed in a circle, the angles that are across from each other, in other words, angle D and angle 125, these two angles are supplementary, which means that they add up to 180 degrees. So if this angle is 125, that means that angle D is 55 degrees. And if this angle is 91, it adds up with C to equal 180, which means that C is 89 degrees. So I have C and D, even though those aren't the first ones I'm going to put in the computer. Those are the ones that are easiest to find first. So why not? From there, I've got to find A and B. So A is this arc right here. But I don't have, I have C, part of C that uses that endpoint, but no line uses this endpoint. So I don't want to use that angle. But I do know that one of my endpoints for A is right here. And this angle that uses that line, it won't find me just A, but it will find this whole arc right here. So if this is 125, then my big arc is twice that, which means my big arc is 250 degrees. But I don't want the entire big arc. I just want the A part of it. Luckily, I know that this part is 99, which means that I just have to subtract 99 from 250, and I can get A. I can get what's left over. So A is going to equal 250 minus 99, which should equal what? 151. So A is equal to 151 degrees. That arc is. Now I need to do the same thing with B. Okay, I'm looking for angle B, and I know that angle A is 151. I'm looking for this arc. So I'm going to do the same thing, but this time I'm going to use angle C. So I know that this big arc right here, all the way around, is double the 89. So twice 89, 2 times 89 is going to equal 178. So this big arc is 178, but I don't want the entire big arc. I just want B. So I want to subtract this extra piece that I don't need, which is 151. So 178 minus 151 leaves me with 27. So B is going to be 27 degrees. So even though I didn't find them in the right order, I still found all of the angles, which is the part that is important. That's the part we care about. Okay. All right. Number 4. Uses a rule that we didn't use a lot in class, but I have 2 lines that intersect my circle. This one intersects here and here. This line only intersects in 1 point, but it wants me to find this angle on the outside of the circle. To do that, remember that I have to take the big arc. So when my lines intersect, it makes 2 arcs. It makes this little red one right here, but it also makes this big blue arc. And to find the angle, I take the big blue arc, 139, and I subtract my little arc that I made, 53, and then I'm going to divide that by 2. And when I do that, it's going to give me this arc right here. Okay, so 139 minus 53, 139 minus 50 is 89. So I need a minus 3 more, so that's 86 divided by 2, which equals 43. So that means that angle Z is 43 degrees. You take the big arc minus the little arc and then divide your answer by 2. Okay, I lost track of numbers. What are we on? Number 5? That was number 4. So yes, number 5 of 15. Yes, there's 15 questions on your test. What is the length of the arc? So I already know that the measurement, my angle of my arc is 60 degrees, but it wants to know, well, what is that actual length? And to do that, we had a formula to find the length of an arc. You took the measurement of the angle of the arc, divided it by 360, and that gave you, instead of using this, arc doesn't go all the way around a circle. It just goes part way around the circle, and that's what this part does. Then we multiply that by all the way around the circle, which is the circumference, which is just pi times my diameter. So in this problem, the angle of my arc is 60 over 360 times pi times my diameter, which is this 11, is my radius. Excuse me. Radius is 11. We want the diameter, which goes all the way across. So my diameter is going to be 22. So don't times it by 11, times it by the diameter, which is 22. 60 over 360 times pi times 22. Now, my answer needs to be using pi. Or in other words, it doesn't want you to actually multiply this pi. So for just a minute, we're not going to multiply that pi. We're just going to multiply everything else, and we're going to put pi in like it's a variable for our answer. So 60 over 360 times 22. So if I do 60 divided by 360, and then I'm going to times that by 22, I get 3.6 repeating, which might be a problem because if I have 3.6 repeating and then I still have pi, it wants an exact answer using integers or fractions. Or in other words, that decimal creates a problem. So to get around that, I need to turn this into a fraction. So math, turn my number into a fraction button, number 1, is going to turn that into 11/3. So instead of 3.6 repeating pi, my answer is going to be 11/3 pi. So be careful that you read how the answer is expected to be put in carefully. Otherwise, you might put in 3.6 repeating, which is technically true, but it wants it as a fraction. Okay, number 6. Same idea, but instead of finding the part of the circumference of the circle, it wants us to find not the entire area, but just part of the area of the circle. So here's my center, and the formula for part of the area is a lot the same as our circumference one. We're going to take the part of the circle that we have. So we're going to take the angle of the part that we're using, divide it by 360, and then we have to times that. So this is the part of the circle. We have to times that by the entire circle, the area of the entire circle, which is pi times r squared. So let's plug in our numbers. My angle is 40 over 360 times pi times radius squared. My radius is 12 squared. So 40 over 360 times pi times 144. Now, again, my answer wants to be in terms of pi. Or in other words, I'm going to pretend like for just a minute, I'm not going to multiply that pi. I'm just going to do 40 over 360 times 144. So 40 divided by 360. And then I'm going to times that by 144. And I get 16. So my answer is going to be 16 pi. I put the pi back in. So instead of finding the entire area, I just took the entire area and I multiplied it by the part of the circle. Whoops, wrong button. I multiplied it by the part of the circle that I had. I had 40 out of 360 degrees. So my answer is 16 pi. Okay, number 7. The circle, other than telling us that x and x are the radius, which, well, we already knew because they're both x's, we're not really even going to use the circle in this problem. I have a right triangle, and in a right triangle, I know that a squared plus b squared equals c squared. So here's my a, here's my b, and this entire side right here is my c. So a squared, 10 squared, plus b squared, which is x, is equal to this entire length, which is 7 plus x squared. So this becomes 100. This stays x squared. My 7 plus x squared, remember, that looks like 7 plus x times 7 plus x. And we have to FOIL. We have to multiply everything. So that ends up being 49 plus 7x plus 7 more x plus x squared. So 100 plus x squared equals 49 plus 14x plus x squared. So I have lots of x's, but I have a plus x squared on the left and a plus x squared on the right. So those are going to cancel each other out. So I'm left with 100 equals 49 plus 14x. So if I minus 49 from both sides, I get 51 equals 14x. So in order to get rid of the 14, I divide both sides by 14. So x is going to equal 51 divided by 14. So if I do 51 divided by 14, I get a decimal, 3.6428. 3.6428. And I'm assuming that it's going to ask to round to the 10th place. Make sure you read the question carefully, but it should ask you to round to the 10ths, which is right there. So x equals 3 point. The 4 makes me round it to 3.6. So my answer would be 3.6. Okay, number 8. Bonus question on the test. I'm going to give you a little bit of information right now. You can use that to try and figure out this problem on your own. And if you're able to, then on the test, you'll get some bonus points. So this is what the question looks like, and it wants you to find C. And the way that one of the things that we can use to do that is some information I know about these intersecting lines. So you have two lines that intersect the circle. And one thing that I know about those two lines is that this distance from A to B, if I take the distance from A to B and I multiply that by the entire length of this, not part of it, but that entire length, which is A to C. So if I take this part and multiply it by the entire line, that is the same thing as if I take this part, the line AD, the segment AD, and I multiply it by this entire piece, AE. So if I take AB and multiply it by the big line, that's going to equal AD multiplied by the big line. See if you can use that to solve this circle for C. If you're able to figure it out, you'll get some bonus points on your test. Okay, number 9, writing the standard equation of a circle. So remember, the standard equation of a circle is x minus h squared plus y minus k squared equals the radius squared. And that's with hk being the center of your circle. We're going to use that formula in the next couple of problems. So the first problem that you're going to get, well, depending on the order you get them, it gives you the center right here, which is nice because I have my h and I have my k. There's h, there's k. And it also gives me my radius, square root of 5. So because I know the center and radius, I can just plug those into my equation. So x minus h, which is -6, squared, plus y minus k, which is -9, squared, equals my radius squared, and my radius is square root 5 squared. So let's simplify. X minus a -6 becomes x plus 6 squared, plus y minus -9 becomes y plus 9 squared, equals the square root of 5 squared. The square root and the square cancel each other out, so all I'm left with is 5. And that will be your answer. You have to write that entire equation to get the correct answer. Okay, number 10 on the review. Write the standard form, but I guess it is going to give you another center and another radius. So my center is -2, there's my h, 0, there's my k, and my radius is 3. So I'm going to use that same formula, x minus h, which is -2, squared, plus y minus k, which is 0, squared, is equal to r squared, which is 3 squared. So x minus -2 becomes x plus 2 squared. And then I add y minus 0 is just y squared. And that equals 3 squared, or 9. So x plus 2 squared, I'm just going to clean this up a little bit because I don't need my y in parentheses. X plus 2 squared plus y squared equals 9. That would be my equation with the center and radius. Okay, number 11, same idea, except this time it gives you a picture that you have to use to find the center and the radius. So center, let's do that first. My center is right here, which is 2 to the left, -2, and it's up 1, 2, 3. So my center is at negative 2, 3. And then my radius is just the distance from the center to an edge. And it doesn't matter which one I count. I just need to count one of them. So that distance is 1, 2, 3. So my radius is 3. So I plug that information into my equation. X minus h, here's k, negative 2 squared plus y minus k, which is 3, squared is equal to my radius, 3 squared, which becomes x plus 2 squared plus y minus 3 squared equals 3 squared is just 9. And then there's your standard equation for a circle. All right, number 12. Find the surface area of a cylinder. So I'm looking for the surface area, or in other words, all of the outside of the surface. And there's a lot of different ways to do this. One is to just find the area of the surface. So you find the area of the circle on top. You find the area of the circle on bottom, which happens to just be the circle on top. And then you just have to find the area of the outside of the can. Or we can use our surface area formula, which really is exactly what I just did, but put into numbers. So the surface area formula for a cylinder is the area of these two circles. Well, I have two of them, first of all. And the area of a circle is pi times the radius squared. So that gives me my two circles. Then I have to add the outside of the can, which is the height of my cylinder times the circumference. That's how far around it goes. And my circumference of a circle is diameter times pi. So it's a little bit messy, but that's the formula I'm going to use, and I'm going to plug in my information. 2 times pi times radius squared. Well, my radius is right there, 8. So times 8 squared plus h, which is my height, 3, times the diameter. Well, if my radius is 8, then my diameter is 16. So 3 times 16 times pi. So let's clean that up a little bit. 2 times pi times 8 squared is 64. Plus 3 times 16 is going to be, well, 2 times 16 is 32. So another 16, that's 48 pi. And in this one, I can do the 2 times 64, which is 128 pi plus 48 pi. Before I type this in my calculator, my answer wants me to put it in terms of pi. Or in other words, I don't want to actually multiply by pi. I have 128 pi's plus 48 more pi's. So let's just do 128 plus 48. So that's 168 plus another 8. So that's going to be 176 pi's. That would be your answer in terms of pi. If it wants you to round a decimal, then you would just actually multiply that and round it the way that it asks. Okay, 13. 7th grade question, so that should be good for you. Find the surface area of the pyramid. Well, the surface area of a pyramid is just all the surfaces added together. So I'm going to start with the square on the bottom because why not? Squares are easy. So that square on the bottom, the area, if this is 13, that means this is 13. So it's just 13 times 13, which is 169. Then I need to find the area of one of these triangles. Nice thing is all 4 of the triangles are the same. So I just have to find the area of one of them. So the area of the triangle is the base 13 times the height of the triangle, which is 12. And then I have to divide that by 2 because it's a triangle. So 13 times 12 divided by 2. is going to give you 78. So one triangle is 78, but I have 4 of them. So I have another one, and another one. And those are all 5 sides of my triangle. So let's just add those together. 169 plus the 4 sides. So I'm going to take the 78 times that by 4, because there's 4 of them. And then I'm going to add the 169. So my area is going to be 481. Of my pyramid. So there you go, 7th grade question. Hopefully you remember 7th grade. Good thing we reviewed it. Number 14 wants you to find the volume of the triangular prism. So remember, this is kind of like a package of saltines, but instead of squares, they're shaped like triangles. And so to find the volume of a cylinder or of a prism of any kind, I just take the area of my saltine, or the area of the shape that's getting stacked. And in this case, that's a triangle. So I'm going to take the area of the triangle and then just see how many of those are stacked on top of each other. So my triangle is 6 feet high by 6 feet wide. So 6 times 6, but it's a triangle, so I have to divide that by 2. And I'm going to get 18. So my triangle has an area of 18. And then I just have to times that by how many of those are stacked on top of each other, which is 9. So 18 times 9, well, let's see, 18 times 10 is 180. So times 9 is going to be 162. And that'll be your answer. If you need an equation because you can't work through that yourself, the volume of your prism is going to be, we did the area of the triangle. So you're going to take your little b times your height for your triangle, and then you're going to multiply that by the height of your prism, your big H. So this is your H, this is your little b, this is your little h. I think that one you can figure out on your own. Find the area of the triangle, times it, how many of those are stacked on top of each other, and you'll be fine. Okay, number 15, our new shape this year. Find the volume of the cone. And that formula for the volume of a cone, remember, you take r squared times the height of the cone, and you divide that, well, technically you times pi as well. And then you divide that by 3. So we just need to find the pieces that we know. So my volume is going to equal radius squared. If I look at the picture, my radius is 3. So 3 squared times the height of my cone, which is 11. And then I'm also timesing by pi. And then I'm going to divide that by 3. So that becomes 9 times 11 divided by 3 times pi. If I look at my answer, it wants me to round to the nearest tenth. Or in other words, it doesn't want me to leave pi in the equation. It wants me to actually multiply that. So let's go ahead and do 9 times 11. And then we had to divide that by 3. And then we have to times that by pi. So 103.672. 103.672. And it wants me to round to the nearest tenth, which is right there. So 103.7 should be what you get. All right. So there's your review. We are testing on Tuesday. Hopefully you get a chance to go through this a couple of times. When you do the questions on the review, remember that even after you do a question, if you needed help solving it, it would be a good idea to click on the similar question button. So after you solve number 15, you can go back to number 15 on the homework and ask it to see a similar question so you can try another one. Would probably be a good idea before the test. So good luck. Let me know if you have any questions.